So we should all be done with the introduction and should be now focusing on linear motion. So in order for us to understand linear motion better, there's a couple of key terms that we should be talking about first. So the first key term is one that we probably use on a daily basis, and that is distance. Okay? So we're all familiar with the term distance. So what does distance mean? Yeah, we're going to use another term to kind of describe that. What does distance really mean? Yeah, we're going to use another term to describe that. Anybody have another way of describing distance? What's that? Okay. Anybody else? Yeah, that's kind of the same one we're kicking around. We've got another word to describe that. Distance is really simple. How far you move. So your definition of distance, the distance between 2 points, is not going to work for physics. In physics, distance is referring to how far you travel in a given amount of time. Okay? So when we're talking about distance, that's what we mean. How far did you travel? Cool? Pretty straightforward definition. The next one is the one you guys have been using. Displacement. Okay? When we refer to the displacement of an object, we're referring to the space in between 2 points. The displacement is the space in between 2 points. Okay. Cool? In addition to that, distance is what we call a scalar, and displacement is what we call a vector. Now, distance just cares about how far you traveled. Displacement cares about the difference between the 2 points and the direction in which those 2 points are separated. So if this is my initial position, this is my final position, the displacement is that distance in between those 2 points and the direction that I would have to travel to get from that point to that point. That's what displacement is. So there is a big difference between those two terms, distance and displacement. Distance is simple path. Displacement is that difference between those 2 points and the direction that it takes to get to those 2 points. Cool? I'll give you guys a few moments to make sure you got that written down. Yes, not only is it the difference, but the direction it would take to go from initial to final. Cool? The last one of these terms is the key one. Position. What is position typically? I know you guys have probably used this in your math class. What do we refer to as an object's position? Yes. When we talk about the position of an object, we're talking about the location of an object with respect typically to the origin. This is this object's position. It's this far away in that direction. Cool? So also it has a direction dependency. So things that have direction are referred to as vectors. So distance had no direction. Displacement and position both have direction. Cool? The alternative definition of displacement relates it to position. Displacement is also the change in an object's position. So when you see this symbol, it's referring to the change of. So when we talk about displacement, we're talking about the change of an object's position. Cool? So if an object started here and moved to here, its change is here. Cool? Give you guys a moment. So we have talked about base units. So what base unit do we use to describe distance, displacement, and position? Meters. So all of these are going to be measured in meters. Cool? So far, so good? Not too bad.